When DIRECTV first launched in 1994, there were two different ODUs. There was an 18-inch reflector with a standard single-output LNB that would provide service to one receiver, and there was an 18-inch reflector with a deluxe dual-output LNB that would operate two, and when connected to a multi-switch could provide signal to multiple receivers. Most installers scratched their heads and wondered why DIRECTV couldn't run everything down one cable like cable TV. Well, the technology just wasn't available. Fast forward to today, where we've gone from one single orbital slot at 101 degrees to 5 primary orbital locations with at least 2 polarities on each, stacked frequencies from 250 megahertz all the way to 2150 megahertz, and 2 different downlink frequencies. Things have gotten even more complicated. Now look at what we've added. Today we've structured our system to provide over 150 high-definition national channels and over 1,500 local channels, in addition to our already superior programming packages that include over 265 channels plus over 65 satellite radio channels. Well, our engineers have been working overtime, and in this session we'll be looking at the new delivery system that delivers it all on one cable, with the revolutionary new single-wire multi-switch LNB, or what we call the SWM. Hi, I'm Ray Edwards with DIRECTV's training department. In this session, we're going to be looking at the single-wire multi-switch LNB, or what we call the SWM LNB. You're going to love it, so let's get started. This is the SWM LNB. The very first thing you'll notice is a single output port. That's right, there's only one. Unlike the original single output LNB that can only provide service to one receiver, the SWM LNB allows you to connect up to 8 receivers off that one output. Not all receivers will work with the SWM LNB, but here's the ones that will. The HR20, HR21, H20, H21, R16, and the R22, or any models newer than these, have or will have tuners compatible with this LNB. Keep in mind a DVR with 2 tuners requires 2 separate frequencies. The total number of tuners you can place on the network is 8, so if you have 4 DVRs, you can't add any additional receivers. Let's look at the advantages to using the SWM LNB and a few precautions. The first advantage most of you will see is the ability to connect 2 tuners on a DVR using only one cable from the ODU. Because each tuner in the HR20, HR21, R16, or the R22 is capable of having its own assigned SWM delivery frequency, you can feed both tuners off a single cable. Another advantage is you may be able to use existing cables pre-run in a home and not have to run new ones. Though we would always like to see only approved RG6 cable with solid copper center conductor, there are times when you just can't get a cable from the ODU to the receiver. If the existing coax cable is in good shape, nothing is in line, and the run isn't too long, there's a good chance you can use it. Before you do, you need to run a couple of precautionary tests to make sure it's good. Here's how. First, read the resistance of a terminator and make sure it's about 75 ohms of resistance. Put the terminator on one end of the cable. Go to the other end and check the resistance there. If it's approximately the same as you read on the terminator, the cable is probably okay. At least you'll know it isn't cut or shorted and there aren't any inline components. Next, remove the terminator you just placed on the cable. Now go back to your test location and make sure you now have an open circuit. This will confirm the cable you have is the right one and that there are no components in that line. Another advantage is you can use a loop system to deliver signal throughout the home. A loop system is where splitters or taps are used to feed a series of sets off one drop the same way cable TV distributes signal. The SWM LNB uses frequencies between 970 megahertz to approximately 1870 megahertz to deliver signals. It uses a 2.3 megahertz control frequency to select the correct satellite feed. Every component in line needs to be rated from 2 megahertz through 2150 megahertz, so it can pass the 2.3 megahertz control frequency up to the LNB and the 970 to 1870 megahertz downstream frequencies to the receivers. That means you have to replace every component in line with one that will deliver those signals. That includes the connectors. Remember, crimp connectors cause problems at higher frequencies. Use only DIRECTV approved compression connectors on all installations. Another advantage in using the SWM LNB is that you have only one cable from the ODU to the house. That means you have only one cable to ground. It also means you'll spend less time routing or attaching cables and cutting on connectors. Let's take a look at how the SWM LNB technology works. Here's how the single-wire multi-switch, or SWM LNB, works. Each receiver is assigned a specific block of frequency spectrum directly from the LNB. The receiver and LNB communicate using a very low frequency of 2.3 megahertz. That low-frequency signal from the receiver selects the proper satellite and polarity for the program requested on that receiver. A designated 100 megahertz frequency block transports signal from the LNB to the receiver in a range between about 970 megahertz and 1870 megahertz. The entire block of frequencies that contain the specific digital information for the channel selected is then sent down the cable at the designated frequency range assigned that receiver. Since each receiver in the system has its own unique block of frequencies, they are all stacked in a row on one single cable and routed to all receivers. The tuner in each receiver is set to receive all its programming information from one specific block of frequency spectrum. Since each receiver has its own specific block of spectrum, no signals above or below that signal range are used. Because the tuner is only looking at the predetermined frequency range, the other frequencies don't interfere. It's by assigning a specific block of the frequency spectrum to each receiver that we are able to stack all those blocks sequentially on one cable and feed them through the entire residence. I'm sure you all know what a B-band converter on every KAKU installation does. It converts the lower 250 megahertz to 750 megahertz KA signals up to 1650 megahertz to 2150 megahertz. With the SWM technology, we need to transport signals in that range directly to the receiver. The B-band converter is not required on any receiver receiving SWM signals. Don't put a B-band converter on a SWM LNB powered receiver. Let's look at the hardware you'll need when installing a SWM LNB system. Since the SWM LNB is unique to DIRECTV, it's essential that you use the right hardware. You can easily spot the SWM KAKU LNB by looking at the output ports. It only has one. When using a SWM LNB, every component has to be compatible. Splitters and other inline devices designed for and used in cable TV distribution networks just won't work. And because we're using different frequencies, every unused port must be terminated. Use standard 75 ohm terminators like this. Let's start by looking at the power inserter that powers the SWM LNB. First, you need to remember that there are two single-wire multi-switch devices. There's the SWM, which is a standalone multi-switch that gets signal from a traditional KAKU 4-output LNB and has one single-wire output and ports for traditional L-band distribution for legacy equipment. Then there's the SWM LNB we're covering in this session. The SWM standalone unit requires a 29-volt DC power inserter, and the SWM LNB requires a 21-volt DC power inserter because these units can't be powered by the receiver. Make sure you have the proper power inserter for the SWM LNB. Also, never connect a power inserter in a way that it can feed voltage to a receiver. This voltage will damage the tuner in the receiver. Another piece of hardware you'll need is the SWM splitter. These come in a 2-port, 4-port, or an 8-port model. You'll notice the frequency range on all SWM-compatible equipment is listed at 2 to 2150 megahertz. In order to align and peak the ODU, you'll also need an alignment signal locator, or ASL. The ASL is connected to the SWM LNB and allows you to look at the signals from the satellites at 101 and 119 degrees independently. Speaking of alignment, let's look at how that's done with the SWM LNB.